Hang on a second.
Good evening, everyone. It's good to see you watching our Twitch screen, everyone with their phones.
Keep it playing games.
So welcome, everyone. My name's Rod Hempel. I'm the Managing Director of Mobile App Development, or Melbourne App Development. And I run this with Kim Philpotts, who's in the background there. Those on the channel won't see him tonight. So welcome, everyone. Tonight, thanking our sponsors. So Melbourne App Development is sponsoring the pizzas. That's us. And Microsoft, thank you very much for this facility, which we wouldn't be running this if it wasn't for Microsoft. So just a few announcements. The xamarin.forms 3.6 is now, do they call it production, released? And that includes the visual component, so that's the material design stuff, which incidentally we're just trying to put in. So I'm hoping that'll go well. Visual Studio Mac 2019 preview is available. Now, I personally don't know much about that, but I'm sure there's lots of information available. This is quite interesting. For those of you who are just starting out, someone in the community I actually don't know who, but they put together this 10-day challenge, and they walk you through step by step how to create a xamarin.forms app, including, I believe, Kim, some back-end stuff there.
Calling REST services, SQLite databases, MDDM, binding, that sort of stuff. So it's a really good starting point for somebody who's getting into it.
How do I get back here?
Click on the first tab. Yeah, first tab in the browser.
Yeah.
Okay.
Now this one is, Kim, can you walk us through this one as well?
So with this one, David Ortenow has put up a challenge for the new visual features. So if you want to take an application or a page of an application that you have done and try it on the new visual stuff, which is where it's basically using material design to try and get the same look across iOS and Android. He's just seeking feedback and got a bit of a challenge going on to see how easy it is for you to migrate the pages, basically.
Now I did notice that he's also got in here a shell. So that's not fully released, I believe, although material design is.
Yeah, it doesn't have to use shell.
Right. And apparently all the cool kids are playing on Twitch, and I think Kim's put this up because he thinks he's one of the cool kids.
Well, we are. This meetup.
Oh, we are, of course. So I'm having trouble with, where are we? Tonight we have a giveaway. So is everyone using LiveXAML? Those that do forms, there's a few nods in there. I'm using LiveXAML and it's awesome. So it's the ability to be able to save a forms and it shows up immediately. So no building your app. So we've got a free one of those to give away tonight, and next month we're giving away another free license. So I think they're like $200 a year or something like that. Very well worth paying for it. As I think I've got 3 licenses, but we're giving away one for tonight. So over pizzas, I'll get you to put your name in a bucket, and we'll just draw out one. And next month we've got another one to give away. So with no further ado, our tonight's speaker is Marc Brady from Orbital8 down in Port Melbourne. Put your hands together for Marc.
Thanks, Rod. So tonight I just want to talk a bit about security of mobile apps, but a bit about me first. I'm Marc Brady. I'm writer of code and Managing Director of Orbital8, one of the writers of code. We're a small mobile development consulting company in Port Melbourne, as Rod just said. I started the company in 2009. I'm actually, and a few of us who are in the company, I'm actually an aerospace engineer by training. So in my former life, I used to design bits of airplanes and so forth. Ended up getting into writing software to design bits of airplanes, and then just decided I like software more than designing bits of airplanes that I don't really see. So that's how I sort of got started, and I got involved with Xamarin in 2011, which in preparing this talk I had a look, and turns out Xamarin was only about 6 months old at the time, which I didn't know. It was called MonoTouch. The product was called MonoTouch back then for iOS. And a bit of tinkering, and then in about 2013 we became a partner company with Xamarin. And since then we've been developing apps for health insurers, logistic companies, in-vehicle driver displays, agriculture, superannuation, medical, just to name a few. It's been keeping us rather busy. So before I get into what this talk is about, I just did want to cover a little bit briefly what it's not about. So security hardening a mobile app involves a lot of aspects, and so I just wanted to focus this, because I'm going to assume we're all mobile developers here. I really just wanted to focus this to what you could do as a mobile developer on the mobile device in your app. So I'm not going to be talking about server-side security. I'm not going to be talking about API security. I'm not going to be talking about authentication authorization. And I'm not going to be talking about network infrastructure or security testing. All of those are super, super duper important things. So don't ignore them. But they are all just part of the overall picture. You need to be looking at the whole picture, not just your mobile app, not just your server, not just your network, etc. So what is a secure app? Secure app is simply one that doesn't really handle anything sensitive or anything important, but that's not very much fun. So really a secure app is one that won't leak a user's private data, or won't leak sensitive data, or won't allow nefarious intended hackers or bad people to use your app to launch other kinds of attacks on maybe not even your system. Things to consider is, what happens if you find a phone on a bus? Are you able to then plug that phone into your computer and download all the data on it? And once you have that data, what can that tell you about the person that used to own that phone? Are you able to get into their email? Are you able to take over their Facebook? Or get root access on some server, and basically what access will that give you? And the other thing to keep in mind is that we write mobile apps and we publish them out in the App Store, we publish them on the Play Store. So the bad guys already have your app. They can sit there, they can decompile that app, they can spend all the time that they want reverse engineering that app, figuring out how to best launch an attack using your app, where the vulnerabilities are. So they've kind of got the upper hand in a lot of cases. So yeah, so you just sort of want to keep that in mind in the context of as you're developing your app. Which sort of just brings me, I just wanted to briefly say something about secure development in general. You can't treat security as a bolt-on, as in you can't write your app, get it all nice and polished and working, and then just say, right, now I want to make it secure. I'm just going to tack on a few features on the end and it's going to be great. Unfortunately, you need to be considering security right throughout the process, from inception and design to development to testing and through to publication even, and through life maintenance. Security is about layers, so you just can't have one measure and say, right, that's going to solve all my problems. you have to have layer on layer on layer of security measures so that any would-be hackers, if they can break or find a vulnerability in one layer, they're hit immediately by another layer of security. And that's at the system level I'm talking to. So it's not just your mobile app, which should have layers of security in it, but it's also the overall system with the APIs and the network infrastructure and so on. And the other one is the principle of least privilege, which is reasonably common sense. It's just don't give users access to stuff they're not going to need. Give the user and your app the least privilege, the least permission that it needs to function. So don't go, for instance, adding all the Android permissions if you don't need all those Android permissions in your app. Don't request GPS access if you don't need to use GPS. Just off the top of my head. And this is perhaps a bit more just my preference. I like to be explicit in the code. So a lot of security features that come out of iOS or Android have sensible defaults. So you might not need to necessarily declare that your app must use HTTPS. But I still like to put that declaration in the manifest that says my app will be using HTTPS and won't be using HTTP. And that's simply partly as a reminder to me as a developer and other developers I might be working with on the app that I've thought about that. That's my decision. And so that's sort of what I mean by being explicit, and through the code too. In even if there might be a safe default, I think it's better to be explicit and actually state that this is the intention, so that anyone that comes along in the future and changes that has to be making a conscious decision to alter the security of the app. So the first step is protecting the data locally. You need to consider what sort of data have I got, and should it be backed up? Should whatever data your app deals with ever leave the app, ever leave the phone that data is on? Is that data encrypted? And if it is encrypted, what do I need to be able to decrypt it, and who has access to that? So that everyone's probably familiar with the data storage locations on iOS and Android, but just as a quick summary, on iOS you've obviously got the keychain. You can store data in the documents folder, the library application support folder, or the temp folder. If you store it in the documents folder, it's available to the user. You plug it into iTunes, they can see the files. You go to the file browser, I think you can get to the files. And more importantly, if you back up the phone, any data in that folder will go into any backup. Temp folders won't, and application support folder will also back up, but you can set a flag on files in the application support folder to say, don't back up these files. So I like to take the philosophy that data that you put in your app, if it can be regenerated, and by that I mean, can I make an API call and pull this data back down again? If it can be regenerated, there's no need to back it up. So as a general rule of thumb, I try to not back up anything, especially anything that's sensitive. On Android, you've got the internal storage and the external storage. External storage you basically need to consider as public and available to anyone. External storage could be an SD card, which is easily ejectable, and plug it into a laptop and you can see files that are on there. Whereas internal storage is the app data private folder. But again, Android has an allow backup flag that you can put in your application manifest. And if you say allow backup false, then no data in the application private folder will make it onto backups and therefore won't leave the app ecosystem, so to speak. If for some reason you need to allow some files in backup and not others, then in iOS you can just flag those files you want to allow backup for, and in Android, again in the manifest, you can declare a policy of which files can be backed up and which not, or which aren't to be backed up. And the other if you've got key values, nearly all apps will have some form of key value storage requirement. Just use Xamarin Essentials Secure Storage. It'll solve 99% of your issues, provided you understand some of the defaults and the nuances of it. So on iOS, Secure Storage is implemented as a wrapper to the iOS keychain, which is a hardware-backed encrypted keychain. Apple goes to great lengths to keep that secure. Every value that goes into that keychain can have I think it's called an accessibility flag, which is when will this value be available? Will this value be available always? Will this value be available only when the device is unlocked? Will this value be available always after the device has been unlocked the first time only? And so on and so on and so on. And also that those accessibility values have an impact as to what parts of the keychain will make it across to device backups as well. So again, like to be a bit more conservative. So the default for Xamarin Essential Secure Storage is that every value is after first unlocked, which just means that the entire secure keychain for your app is available to your app after the device has been unlocked after the first boot of the device. And it will also mean that any secure storage values will be copied in backups across to other devices and other phones. But if those key values are regeneratable via APIs or whatever, then I like to set after first unlock this device only, which means that value will never leave the device. And the most secure value, if you like, or the most restrictive value is when unlocked this device only, which means as soon as you sleep the screen, the keychain's inaccessible again. But that's going to potentially cause some backgrounding problems if you're trying to save data, because you never know when a user's going to sleep the screen. And if your app is suddenly trying to persist data milliseconds later, it won't be able to access the keychain. On Android, secure storage is implemented as an encrypted shared preferences file. Now, a shared preference file is a bit like a key value text file, like an ini file for the old Windows users. It's encrypted with the key. It's stored in the Android hardware key store. So it only supports API 18 and above, so it's asymmetric encryption up to API 23 and symmetric above. Not that that's a huge concern, but probably what is notable is that going back to the backup, you probably want to exclude the encrypted shared preferences file from backups in the same way that we were just talking earlier. Just a other little side point, iOS provides file encryption in much the same way you can set key value accessibility values in the secure key store with iOS. You can also set file encryption accessibility values at the file level. So you can say this file, the file system is encrypted on iOS anyway, but you can say this file is only available after the device first unlocked, or after first unlocked and this device only, or only when the screen is unlocked, and so on and so on. So you can just, it might be worth considering what appropriate options there are. Now the fun bit, how do you protect the data that's coming to and from the app? So basically over the internet. So the first, you got to get the basics right. You should be using HTTPS. It's 2019 now. There is almost no excuse not to be using HTTPS. Certificates are stupidly cheap, and just about every public API I can think of is HTTPS. And in fact, both Android and iOS are probably enforcing that now, in their defaults anyway. Use the latest TLS, and that I'm bordering into server territory a little bit, in that you should be disabling all the ciphers on your server less than, say, TLS 1.2 is probably pretty good these days, and less than that would be starting to get dated.
I found a script that does that. It's a PowerShell script program. There's a couple.
Right.
One's got a bug in it and one works. But you just run it on your Windows server and it's magic.
Yes, there's another. There's one that has a GUI for if you use IIS as your server. There's one called IIS Crypto, which has a little GUI, and you just say, I want PCI compliance, or I want the most secure available, and it will enable and disable different ciphers for you. Both iOS and Android have their own app security config as well. On iOS it's called Application Transport Security. On Android it's called the Network Security Config. Essentially, this is where you declare to the operating system, my app will only use HTTPS, but I've got this legacy web link that I need to call that is HTTP, and unfortunately I can't do anything about it because it's not mine. So I have one exception here that I will allow unsecure or non-encrypted loads of this URL. So you do it by exception. So avoid things like NS allows arbitrary loads, because that basically says your app can call whatever it likes to whoever it likes whenever it likes. Which if someone's putting in some malicious code into your app, then that's giving them carte blanche to do whatever they like. Android's equivalent is clear text traffic permitted. Avoid setting that to true for the same reasons. Now, Android also has this ability to configure what they call trust anchors. Basically, it's I'll dive briefly into how HTTPS works, but the very first couple of milliseconds of an HTTPS connection, the phone and the server are negotiating how they're going to be encrypting data. So the server's saying, here's my certificate, and the mobile phone is going, oh yeah, I see your certificate. That looks like an acceptable certificate to me based upon ones that I trust. It's been issued by a trusted certificate authority. And those trusted certificate authorities are a set of root certificates that are published out on your phone by the device manufacturer and periodically updated. They're called system trust anchors in Android speak. In Android, users can also install their own trusted certificate authorities, and they're called the user trust anchors. Unfortunately, it's probably reasonably easy to human engineer someone to install a certificate in the user trust anchors without really understanding what they're doing and the implications of that. And then all of a sudden, the system will start trusting that. So if I was a nefarious hacker, I just need to get my certificate installed on people's phones in that user trust anchor, and then all of a sudden I can start launching attacks on the phones that have that installed. So I like to declare in the app manifest that this app will only accept the system trust anchors, not the user ones, so that even if the user has installed a few extra ones by accident, maybe not understanding what they're doing, then the app simply just won't accept that. So then once you've done all that, how would an attacker snoop the network traffic? And some of you may have heard of a man-in-the-middle attack. It's the easiest and simplest way by which data can be leaked through a network connection. Basically, it involves setting up a proxy. If you've ever used Fiddler, if you've ever used Charles Proxy or any of those sort of tools, you've got all the tooling you need. But I could set up a Wi-Fi router and sit down here in a freshwater place and just set the SSID of my Wi-Fi router to be free Wi-Fi, come one, come all. And then in a few minutes, people will start signing on and using it. And in the meantime, I can be looking at all the traffic that's passing through out to the internet. And I can legitimately be taking requests for Facebook or Gmail. When I see a Gmail request, I can go to Gmail and say, Gmail, I've got a request for this page, and then decrypt the traffic on my side, and then re-encrypt it with my certificate, and then send it back to the device. Now, if that certificate that I'm re-encrypting traffic with has either made it into the user trust anchors or comes from a trusted certificate authority, which in the system anchors, users are probably not going to be aware, other than the name of the certificate is going to be different to what they would expect. So you can actually snoop traffic, even HTTPS traffic, and users wouldn't be aware. So what's the mitigation for that? It's certificate pinning. Basically, certificate pinning is the process of building into your app that your app will trust one and one only certificate for talking with, the server with. So if your server, presumably we manage the server side, whether or not it be directly or indirectly. We know which servers we want to talk to. So you can get the certificate, because the public key or the whole public certificate, or just the fingerprint of that certificate, and you can embed that into your app and say this app will only talk with that certificate, or servers presenting that certificate, I should say. And then all of a sudden, man in the middle becomes really difficult, and that you can almost get to almost 100% certainty you're talking to the correct server.
Basically, you're effectively saying, use this wildcard certificate is valid.
It can be a wildcard certificate, potentially, yes.
Does it need to be the certificate, or is it just the URL of the wildcard?
No, it needs to, you can pin to different points. So you could pin to, server certificates are issued by a root certificate authority, and there can be intermediate certificates before you get your server certificate. You could pin to the leaf certificate or the server certificate, or you could pin to any one of the intermediate ones. You could also just pin to the public key, in which case then, as long as the keys don't change each time you change the certificate on the server, you don't have to change your app.
That's what I was coming to.
Just depends on what you're comfortable with from a security point of view. If you're happy to accept anything issued by DigiCert, then you would pin to their root certificate authority, but that might be a little bit too open. Or you could just pin to the public key of the actual server certificate, and then just keep using those same keys every time you reissue the certificate. So, all right, there's some minor drawbacks to certificate pinning, which we just touched on there, which is basically if you pin against the fingerprint or the actual certificate itself, then every time that certificate expires, you're going to have to reissue your app. So it's probably best practice to have your app accept a list of certificates, and then you can say, well, I'm going to accept this old one and this new one that's going to come into production in 6 months, so that there's sort of a rolling trust, if you like, built into your app. So if that's too uncomfortable for you, well, then I would pin against the public key and just make sure you always use the same public key. And the other downside is that your app's not going to work through proxies that decrypt and re-encrypt traffic, because that's kind of the point. So if there are free Wi-Fi's, maybe they're legitimate, but they're just very poorly secured, your app's not going to work on a hotspot in that situation. It's also not going to work in China. If you've ever heard of the Great Firewall of China, that's exactly what they do. They decrypt and re-encrypt HTTPS traffic. So you could, if that was a huge problem, you would need to get the fingerprint or the public key or the public certificate of the Chinese firewall and embed that in your app as well. But obviously the traffic can then be snooped. So how would you do that? I'll just step out of this briefly. So this is just a skeleton xamarin.forms app, just for the purposes of demonstrating this, and all it does is hits some public data API that I found when I was preparing this that happens to use HTTPS, and this is just some random test data. Puts it into a list, nothing exciting. But if we then dive into the code, I have a service that makes the network call. Now, normally, in most of your apps, you probably have a line like this somewhere in it that would construct the HTTP client, and you would use that to make your API calls with. Now, you may be familiar with some of the options in Visual Studio, specifically for iOS, this option, where you can choose what client handler that HTTP client will use. Now, it defaults to NSURL session, which is a nice default. That basically means that every network call is going to drop down into iOS land and use iOS's platform NSURL session to make the actual network connection, get the response back, and then bring it back into C# land. CF network is just there for legacy. Managed is the other option, but managed just means everything's going to be in C# land. There's nothing that goes out to the platform. There's a performance difference. So you probably, it's why NSURL session is the logical default, because it's faster. It's not working in the managed space. But yeah.
Is there a legitimate reason to use managed anymore?
Well, certificate pinning is really stupidly easy in .NET if you use managed. But because there's .NET has a service point manager .validate server connection callback, which every HTTPS connection, that callback happens, and then you can do all your server validation code in there to say, I'm going to accept this certificate, or I'm not going to accept this one, and so on and so on. Problem is, that callback only gets called with managed. But me being stubborn, I don't want to use the managed one. I want to get my performance of NSURL session. So we have to look at another approach. Now, before I go into the approach, let's just talk about Android briefly. So the equivalent options on Android, if you've ever looked, this one here. Basically, the managed client handler or the Android client handler. The Android client handler is using Android's own networking, and including OKHTTP, I think, which is now part of Android. Same issue though, that if you choose the managed one, you can use this service point manager callback. But if you choose the native one, you don't get that callback. So you have to do platform specific code. So what I've done is I have a little factory class that constructs my HTTP client for me. And I have an Android implementation and an iOS implementation. So we'll go to iOS first. So this is the implementation of that. It merely constructs the HTTP client, but injects my own custom handler, which is really what Xamarin's doing for you under the hood anyway, with those build options. But in the case of my handler, I'm inheriting from, now normally you'd be able to inherit directly from NSURL session handler and then just inject your own code. However, just in preparing this talk, I found a bug in my code. So what I've done is I've brought in the modern HTTP client native message handler. But so this is just copied straight from modern HTTP client. All this code does is wraps the HTTP client call into an NSURL session call and gets the response back and wraps it back up to HTTP client responses. You could, and what I want to do, I need to find the source of this bug though, you could just go straight to Xamarin, the Xamarin GitHub repository and copy their NSURL session handler, bring it into your app and add the callbacks that you need so that you can then do the pinning. Unfortunately, the Xamarin's NSURL session handler and the Xamarin's Android client handler don't provide quite the callbacks needed to stop an SSL connection if the pinning check fails. So that hence why I've been copying the code into my project and then adding in the points, the injection points, if you like. Having said that, I was looking at an issue on a GitHub repository in the last week, and it sounds like they're working on a callback for these native client handlers, which will basically solve all this, so that you would just inject on that one callback where you would put your pinning code, which will simplify the world hugely. So in the native message handler, so in iOS land, there's a did receive challenge. This is an iOS callback, and a whole bunch of checks happen here. But the last port of call, if you like, before we say that this is a good connection, I've injected this check here. If validate trust chain is some method that I've created, if it says this is a valid trust chain and it passes in the host name and the array of certificates that the server is presenting to us, if it passes, then we will use it and call this completion handler, which is how iOS does it. If it doesn't pass, then we need to cancel everything, stop, don't allow this network connection to happen. So back at the pinning session handler, which inherits from this is the actual implementation of that. Basically, I'm just saying, is this a network call for an API host that I'm actually pinning against? If it is, then we'll actually do the pinning check. If it's not, then I'm allowing the network connection to happen because I'm assuming this is not going to be one of something that is super secure. It's probably a web request out to Google or something. It's a lot of the apps that we've done, you often find that there's a link to a terms and conditions page or a privacy policy or something like that, in which case just allow the web request. It's not super important. But all the API calls, we want to make sure they're pinned and can't be snooped. So if we pass that first check, we need to get the certificate. In this case, I'm pinning to the actual server certificate itself, hence the first one in the chain, the index 0. Get the certificate, and now I'm just pinning against the thumbprint of the certificate. I could be pinning, as I said earlier, pin against the entire certificate or just the public key. And then, does it match one that I'm expecting? If it matches one I'm expecting, great. If not, return false and we'll cancel the connection. On Android side, yeah, it's probably worth noting on Android the API 8, I think, they're introducing some of the certificate pinning into the app manifest itself. So you could declare the pin that in the app manifest that you want to pin against, but it's not going to work backward compatible. So hence, well, actually two points. It's not going to work backward compatible, so I still have a preference for doing this in code, but also it's a sort of a standardized way. So if a hacker was going to take your app, which I'm going to get to a little bit shortly, take your app and modify the manifest, it's a really easy spot for them to go straight to and just go, oh, there's the pin. I'm just going to put my own pin in there. Thank you very much. And then all of a sudden a new pin will be accepted. So again, I still got a preference for doing it in code, so it's a little bit more obscure. Now, security by obscurity is not security, but it's just an extra little hurdle. So in Android, this time we're inheriting from the Android client handler, and in this particular case, I have copied the code from the Xamarin GitHub repo directly. So this is basically Xamarin code here, but I have injected a callback in the same way. Just got to find where I injected it. We'll find it the other way. So I've put this into the Android client handler and had it, and I'm calling that just after the HTTP connection is connected. And now that's important, and that's one of the callbacks that the Android client handler won't give you without modifying, because when we come up to the pinning level code, we can override this configure the socket factory callback, which they do provide, and here we can set up using, this is just Android code if you like. We can set up our own trust managers, and specifically I'm creating a trust manager extension class, which after the HTTPS connection has been established will allow me to then validate the pinning, but I can't do the validation until that connect call has happened. And the pinning call, or the pinning check, is again similar. Just check that this is a host we want to be pinning against. And in this particular case, I'm actually only doing the pin check against certificates that are already trusted from the system trust store. So it's kind of an extra little check, which was causing a colleague of mine some consternation today. And then, is it the expected one? If not, throw an exception. We're going to stop this connection right now, and we're not going to allow anything to proceed. So what does that look like when you run it? So now I'm going to, I use Charles Proxy on Mac for, so if, I might just restart that, sometimes it doesn't work. So Charles Proxy is now essentially snooping every network connection coming from my computer out to the internet. So you can see them all whizzing past. Fiddler's the equivalent on Windows, which Fiddler's a very good product. It just doesn't work very well on Mac. So there's the failure, and you can see if I turn off SSL proxying, that connection will go through. And if I start snooping SSL connections, and as in decrypting them, even though I've said Charles' certificate is trusted on this iOS device, the app simply says, no thank you, that's not the certificate that I'm expecting it to be. And the HTTPS connection is failed. So there's no data that you can see, whereas on a successful connection, you should be seeing encrypted data. And just moving on. So having done all that effort to make sure that connections to and from the app are now secure, and data that's stored within the app is now secure, the only last, well, I shouldn't say the only, the most obvious vector for someone to attack is your app itself. So you need to think about how's your app being distributed. If you're distributing via the iOS App Store or the Play Store, you've got some known distribution channels, so that's useful for tamper-proofing your app. So some of the sorts of things you could do. In iOS, first of all, app distribution is heavily controlled, which is a blessing in this particular case because they require you to code sign the app with their trusted certificate, and every iOS device has the trusted root certificate baked into it. So if it fails code signing, your app's just not going to run. So a lot of the difficulty of tampering of apps is solved for you on a regular iOS device. On Android, however, code signing, it's a free-for-all. You can make whatever certificate you like and code sign it, and it's going to run on any Android device. to the point where I can go to the Play Store, download an app, open up the manifest and inject my own certificate pins or inject malicious code and re-sign it with my own certificate, and then every Android device will run that. It's indistinguishable. I won't be able to distribute it via the Play Store, but I'll certainly be able to put it up on the Amazon Android store if it wasn't already there, or I'll be able to email it around to people, or I'll put it up on a website. And if the pedigree of that app's not known, it could be re-signed with a different certificate and have potentially malicious code within it. So tamper-proofing is more about, in my view, the biggest risk is probably Android. And some of the sorts of things that you could do is you could check your app's not debuggable. You could verify where it has been installed from, and then you could actually compare the binary signatures of the Android package itself, the Android manifest itself, against a known signature. So checking it's not debuggable is really easy. Just if the application flags has the debuggable flag, you should be turning that off on any production released app anyway. So, but again, it could be modified after the fact. So you probably want to just a check like this, and then don't establish network connections or warn the user or shut down the app, or I don't know what your resulting strategy might be.
So is that just the difference between a debug and release build?
It's the difference between there's a flag on here. Sorry, not on the activity, on the application. On the application manifest. Oh. Yes. There's a debuggable attribute there, just true false. You can. I tend to. I haven't done it here, but I tend to have a custom application.cs to my Android apps, and then just do it with attributes to turn it on and off with conditional compiles. So I can say for a debug build, the debug attribute's there. For a release build, it's not. That's an Android specific thing. And then other sorts of check, the other verifying where the installer, where was this app installed from. You can ask the package manager, what's the install package name? If it starts with the Play Store installer prefix, which is that, then chances are it's been installed from the Play Store. I mean, again, none of this is definitive, but it's all evidence that it's likely tampered with or not. And then lastly, validating the signature. This is probably the most definitive, is that you can say to the package, give me the binary signature of the Android app itself. And then just like we're comparing the certificate pin to a known expected value, we're comparing the binary signature of the app to a known expected value, in this case, a SHA of it. And I've set this particular one up to basically reject network connections if those checks fail as well. Maybe that's a little bit heavy-handed. Maybe you just want to do it once at the start on app launch, or it depends on the app, I guess. Code signing we talked about, which also brings me to code obfuscation. For a long time I was not a fan of code obfuscation because I just felt like it was your code should be secure without it, and obscurity is not necessarily security. However, in this particular case, we're putting values into the app such as expected fingerprints of certificates or signatures of binaries, and the actual method itself for doing the certificate pinning. Again, just another layer of difficulty in a hacker trying to figure out which method should I inject or modify to return true or false values. it's not necessarily going to be definitive again, but it's just another hurdle for them to get over. It's probably a worthwhile step. And then last thing I really wanted to say was just a comment about jailbroken devices and rooted devices. In a jailbroken device, which for iOS, and rooted device for Android, all bets are off. Basically, jailbreaking a device and rooting a device is removing a couple of fundamental layers of security out of the Android or iOS operating system. And you can't, unless you know the exact pedigree of a ROM that's at least in Android space, you can't really know what's going on. Malicious code could be running. You've got not necessarily any control over it. There's not a lot you can do other than you can pin, you can tamper-proof your app, but you don't necessarily know if the operating system itself isn't compromised. And there was what was it called? This is exactly what happened in 2015. There was a malicious bit of software called Key Raider that was piggybacked onto apps for iOS and distributed around via the jailbreaking websites and so on. And its sole purpose was to just snoop iCloud credentials and then post them off to someone. And non-jailbroken devices weren't vulnerable to this simply because they won't run non-Apple code signed software. But the jailbroken devices, and I think it was 250,000 new credentials were leaked that way. Unfortunately, there's not much you can do about it other than there are various ways of detecting jailbroken devices or rooted devices, but those methods are only as good as the latest known methods for jailbreaking and rooting devices in the first place. So there's always the chance that a device will be rooted or jailbroken and your code won't detect it. But it might be useful to warn a user. It depends, each case depends, I guess. That's about all I really wanted to say. Does anyone got any questions?
With the certificate pinning,
Mm-hmm.
so with the thing that Facebook did a while ago where they were installing root certificates on people's phones and paying them money for it, did you hear about that?
No, I didn't, but that sounds like they're putting them into the user's trust store.
So they were paying people, I think, $50 a month or something, and where it really came out in court was that they were doing it with people down to age 13, and people were saying that they were consenting to Facebook looking at their data, and Facebook were then going through all the data on the phone.
Yes.
Right.
They used an enterprise certificate that had been issued to them.
That's what they,
Yeah, so they used their enterprise certificate to install a VPN.
that's right.
Yeah.
Would
Right.
this certificate pinning,
Into their own client.
would this certificate pinning make your app safe from that?
To some extent, yes. Your app would be, yeah, because it will only talk. Other data on the phone is open to potentially, but your app, if pinned against a specific certificate, even if it's going over a VPN or it doesn't really matter what network connection it's going over, it will only handshake and encrypt and decrypt traffic with the one and only certificate that you've said, or more, might be 2 or 3 certificates, but the ones that you've said are the good ones.
That's only true for the HTTP clients that you control, though, right?
Yes, yeah, absolutely.
If you, for instance, brought in a library like your analytics library, and it's
Good point.
its own HTTP request, it's not.
Good point. Yes, yeah, that's in iOS. That is definitely the case. What you've just said. On Android, if the way I've done this, the pinning here, using they call them trust managers. That's setting up the conditions for the whole app.
Okay.
So that is more likely to work across third-party libraries. Again, the short answer is it depends. You could have a custom client in a library that doesn't touch anything operating system whatsoever, in which case none of this would work here.
So it's worth keeping in mind not putting sensitive data in your analytics.
Well, yeah.
True. True.
One of the things you can also do on the server end, which we do, is we log the IP addresses of the clients coming in. We have both web, desktop, app, etc. clients. And if the user's IP address goes out of country, we turn it off immediately. Because unless they've said they're going, and in our case, because we work in the health sector, we've got people in Australia or Korea, for example. If the person in Korea is not in Korea, we don't talk to them. And they get locked out. And it gets logged, and I get a message on when I wake up the next morning and somebody tried to get in from here to here to here to here to here as the administrator. But that's another level that you can include into it.
Yeah, absolutely.
But you can also include the domain it came from. And if you pick up the domain, you can then log the domains, even if it's a mobile app and it's on, for example, Optus, you know it's coming through the Optus gateway. You can pick that up. If it all of a sudden appears on Telstra and you don't know about it, then you can sort of go, what's going on? Or it appears through something else. So you can, at the server side, also get visibility in that space. Pick that up. It's a nuisance at times.
And you can even go to the point on server side is validating the client. So the client.
That's exactly what we're intending to do. By putting effectively a certificate in the client and coming back and saying, well, the public certificate, yes, does it match? Yes. It does. In which case I'll talk to you. Otherwise, basically, piss off.
Yeah, exactly.
I've got a question from internet, which is, any recommendations or experience with obfuscation products for Xamarin applications?
Probably the two main ones I would suggest are Obfuscator and Babel for .NET. Both work reasonably well with Xamarin and xamarin.forms. I've used another one called Crypto Obfuscator, but it doesn't know anything about Xamarin specifically, so you probably don't want to be obfuscating your XAML and things like that, where it will, because there's a certain level of reflection used with some of these, with XAML and xamarin.forms, and Obfuscator will just ruin all of that.
Break it all.
So, but you can put exclusions in to say this bit of code, all right, so a hacker will see your XAML layouts, but if they can't get to the networking stack and the service side of stuff, it's probably more what you're concerned about anyway.
Well, the other one is to put things internally. If you've got lots of DLLs, your obfuscation is going to be compromised. Because each DLL interface has got to be open. Otherwise, you can't call it. The way to get around that, we did this for a web app some years ago with some guys in the States. Basically, we had a 3-tier stack. So we had DLLs for data layer, business layer, logic, models, all that sort of stuff. We basically put it into one compile library, and then the only thing that broke it was actually ASP.NET, because it wants public IDs. So you cut that off at that point, but everything underneath there, down to the database, was completely invisible to it. And the obfuscation basically became numbers. And it made it really, really hard to decompile. I don't, if anybody's interested, I can look up the name of the company, because they actually insert into the code certain breakpoints into the actual code that if you come in and try to decompile it or do their other bits and pieces or monitor how it's executing, it deliberately throws failures in that are not obvious.
A lot of them have tamper checks like that.
So if you try to, if the CRCs change on something or other, all of a sudden, depending on how long it's been going for, different levels of tampering will come up, and all of a sudden you'll find a thing weeks later will all of a sudden crash.
And we've got pizzas and rice, so any more questions?
I was just going to ask if the code that the demo code you had,
sure.
made available?
Sure, As I said, I really wanted to get the Xamarin, so the NSURL certain handle code working, but it's working as it is.
Someone will do a pull request.
Yes, good idea. Good idea.
Well, I think we should finish up there. I'm sure Mark will take some questions over pizzas. Thank you very much, Mark. It was excellent.
All right, thanks.